30 to 50% of your fractures produce 80% of your hydrocarbons.
That lends a lot of credibility. If you come in and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on over 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean.
Here's your new colors, here's your new thing. We don't do that
at all. Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hello everyone. Welcome to the Locksmith door. I can't say it.
The door locksmith.
The door locksmith.
Hello, everybody, and welcome to the V-Door Locksmith Show. I'm your host, David Gibson, where we are unlocking the secrets to success in the oil and gas industry. One interview, one technical presentation, and one technical screw-up at a time. I am so happy to have everybody here with us watching today. Thank you guys for all of the support. We really do appreciate it. Let us know where you guys are watching from. Love to be able to give everybody a shout out here on the screen. We've got an amazing show for today. If you guys are the least bit interested in things that are related to geothermal drilling, high temperature drilling, as well as some just really, really cool mechanical stuff, today is the show. We've got amazing guys from Full Metal Power to be able to come in here and talk to us. So once again, if everything's working, also please let me know if just the audio and everything's coming through. I know we've had some issues in the past recently about that. So glad to be back in Texas. Spent last week up in Alaska. Had an absolutely amazing time up there. We put together, or Gibson Reports was a donor to the Alaska SPE section. We put in $500 for the student scholarship. So all of that went really well. It was really interesting to see that not only Hillcorp, but also SLB or Schlumberger, whatever you want to call them. Hell, you can call them Anadril for all I care. Put in the exact same amount in the scholarship fund as we did. So as far as percentages are concerned of total revenue for the company, we were definitely the highest out of everybody there. So it was really, really great and to be able to see and meet everybody up there. They've got an amazing group of people. Oh, never mind. They're just stretching a hand. I thought I was getting a signal from behind the scenes there. All right, guys. So we'll go ahead and start giving everybody some shout outs. I know, let's see, we've got somebody giving us the Samil, yeah,
Sammy.
Hook 'em horns. Oh, Sammy, you know?
Yeah, I know Sammy.
Oh, okay.
Hey, Sammy.
And then also, as always, John DeWart, being able to get in there. He wasn't first today. Sammy got in just a slight bit ahead of him. Usually it's John DeWart's usually first. So Jeff, just tuning in. Thank you for being here, sir. LinkedIn user, which is John, tuning in from Texas Hill Country near Driftwood. John, you just need to come Yeah, I mean, literally, just need to come be in studio audience. You're here almost every Friday, so come stop by that, or just come be on the show one of these days. Tell us a little bit about geosteering. All right, Maxime from Ukraine, thanks for being here, sir. Appreciate that. Sammy, somewhere in Hobbs, New Mexico, somewhere around Hobbs, New Mexico. I feel that. Like
right.
just being somewhere and you're like, I'm somewhere near Midland.
In the empty quarter.
Yeah.
Middle Earth.
Yeah. It can be deep hole drilling. I agree. We can do some deep hole drilling. Curtis Cheatham from North Houston, and he's from one of our proud partner of the show, Corva. So thanks for being here. Tongi Bashir, that's my guy right there, from Stormy, Scotland. You met Tongi? Have you met him?
I don't know.
Super smart guy. He used to work with me at Lodestar. Great guy. Andrea Switzer, a former guest of the show. We'll have to run that one back because we got a ton of questions for that one. So Andrea was great. Robin McMillan tuning in from the Canada. Thanks for Robin. Robin, former guest on the show, and now the SPE technical drilling president or whatever.
Cool.
Yeah. So great to be able to have him on here. All right, who else we got tuning in here? Robert Essie's tuning in from Tomball, and he's watching on YouTube. So, quick update. If you guys are having any problems watching the show with LinkedIn, this has been happening a lot. It happened for JP, it happened for myself, Keith Stelter, a couple of other people. If you're having issues watching on LinkedIn, just switch over to YouTube. There's some sort of problem with the LinkedIn live streams that's been going on. If you're not, fine, just stay where you're at. If you need to, switch over to YouTube. Might help you out. Darren tuning in from Magnolia. Thank you for being here, sir. Andrew says audio is good. Video is a bit fuzzy for me, both on LinkedIn and on YouTube. Okay. Well, maybe I'm just a fuzzy creature running the countryside. All right. LinkedIn Tongi Bush here. It was sunny Scotland. We would be disappointed. If it was sunny Scotland, we'd be disappointed. All right. Lynn, good to see you, David. Yeah, and great discussion today. Lynn was on the panel at the Corva event. He's over there with Halliburton. So we talked about his cerebro technology.
Oh, yeah.
Really, really cool stuff. Is one of those people. It's like, you ever end up doing something in the industry that's, you've got the competitors and then you get out of it and then you can come back and commiserate with the people that used to compete with you and like share war stories and stuff. I'm definitely like, that's where like Lynn and I are at. So, all right. Next up, Gabriel, I think. Regards from rainy Europe. Thanks for being here, sir. Hopefully I didn't butcher your name. Buenos dias from Colorado. Jorge, thanks for tuning in, sir. And David Thill, all good on LinkedIn. Well, thank you guys all so much for being here. Really do appreciate it. All right. So as per normal, we're going to give away ourselves a drill bit. I've still got one more pink one hanging around. I believe this one is going to be for Janie Snelson. So if anybody wants to tag Janie in the comments, please do. But put in hashtag Corva right now for your chance to be able to win a drill bit. We'll get one of these sent off to you here shortly. We've got 20 of these on order because I cannot make them fast enough. I did, however, buy a new 3D printer. Can't wait. It can print out some giant ones. So we'll see who's going to be the luckiest one to get that. So many thanks to Corva for helping out with the show and being able to bring us some amazing data and insights. So this is your Corva Insight of the Week.
Over the last 10 years, there has been a significant rise in the uptake of artificial intelligence and machine learning to develop solutions for efficient operations across the oil and gas industry. There is an increased focus on building data science teams of people from diverse backgrounds as the field of data science lies at the intersection of computer science, mathematics, and domain-specific expertise. Using domain knowledge at every stage of the data science workflow is critical for the success of the project. First step is the problem formulation. Domain knowledge can help us to find precise and accurate problem statement with an objective to deliver a solution that can be easily understood and adopted by the end user. Having the proper domain insights can also help with reducing the burden of collecting large amounts of data that may not be necessary for a specific problem. In addition to ensuring better data quality, Domain expertise may also be used for creating training data using physics-based models. Finally, having the right domain knowledge is critical in the exploratory data analysis stage, where we need to validate the fundamental physical relationship between the input features and the target variable. We can also use engineered features that may not be directly available in the data input. Following these practices significantly help reduce the time and effort required to train machine learning models that are interpretable for end users and deliver effective solutions for improved operational efficiency.
All right, guys, thank you. That was your Corva Insight of the Week. All right, I can't see from here. My glasses are not that good to be able to zoom in on what that says as far as how many.
20.
Oh, 20. All right. It's not bad. All right. So if you haven't done it already, time to put in hashtag Corva onto the screen so you can be a part of the quick little giveaway. Let's see. 5, 4, 3, 2, 1. And Mr. 21 missed it. Or Mrs. whoever. Pronoun of choice, whatever you like. And our winner for this week is Andrea Switzer. I think she's already won before. Hasn't she? She's won twice already. We do. All right. Well, I mean, hey, that's how the game's played. You never said you couldn't win twice. I mean, I'm not writing a whole bunch of rules and regulations or anything like this. I'm just happy that people are participating. All right. So, Andrea, thank you so much. I've already got your address. I think this might be like she's probably won twice in 3 weeks. Nice. Something like that. Yeah, well done. All right. On with the show then. All right, so welcome to the show. Thank you guys so much for being here. Aaron Baxter, thanks for being here. Live and in person.
Live and in person, yeah. I was able to drive
then
down.
first time ever for the Vidor Locksmith.
Yeah.
Also on the show, Hans-Henk Walters.
Yep.
Live on the remote side of the business. On the remote side of the show business. Thank you for being here, Hans. I appreciate it.
Thanks for hosting the show and having us over. Thanks.
All right. Well, do this. Who wants to go first?
Let's have Hans start.
Okay,
Yeah.
Hans, give us a quick introduction of who you are for anybody out there who doesn't already know.
Thanks. Yeah, Hans-Henk Wolters. We're running the company Full Metal Power. What we have done is modify the current power sections to something without an elastomer and now introduce the metal-to-metal power section into the industry and have eliminated the rubber, and that creates a lot of benefits.
So, real quick, how did you get into?
Yeah, no, that's a good.
That's fine. That's fine.
No. Go ahead and introduce.
Aaron Baxter. So I'm doing global business development for Full Metal Power. Hans-Henk and myself pretty much cover the globe as far as anything to do with Full Metal Power in the business. We are sales. We are everything, all encompassing.
You are bright.
Yeah.
Just
like our shoes and our shirts.
Yep.
Yeah.
I need a bright orange shirt.
Yes, you do.
I've got a bright orange polo.
We can arrange that.
Oh, you're going to get me a bright orange
Hans, that's the national color of the Netherlands. So Hans is going to be able to hook you up.
I do have my glasses now.
Oh, you the glasses. Yeah.
Yeah. I had to paint these myself. Actually, I didn't do it. My girlfriend did. All right. Anyways. So Hans, give me how did you get into doing metal power sections? Like what was your background?
Yeah, so I've never been on a rig. I'm not from the industry. I'm a chemical engineer and have worked for over 25 years in chemical engineering and specifically electrochemical machining. And this is a technology that I started with for the Phillips shaver, which is known in the US as the Norelco shaver. So the 3 heads on top of the Phillips shaver, these are made by a process called electrochemical machining. And that's what we have done for 25 years. And the first introduction into stators was back in 2009. And we built a dedicated stator machine in 2014. And metal to metal, look, designing a metal to metal power section is no rocket science. Cool. A metal to metal design is no rocket science. Everybody can build this rotor. But the holy grail is being able to make this stator within a hair thickness of accuracy over feet of length. So let's say 7-8 feet in length with a head thickness of accuracy. That creates that sealing like you have in hand there between the rotor and the stator. And by having that tight seal, makes it feasible to have the performance that you're looking for. And that's the capacity we have here in the Netherlands to profile rotor and stator so accurate, so that it's really gonna work.
I feel like there's a story there that you're not telling me. How did you go from Norelco shavers?
You want to know all steps in between?
Well, not all the steps, but I mean, like, was it just like a random time at a bar and somebody's like, "Oh, you make shavers? Oh, you know what else you should make?" Like, go from these tiny little razor blades to this giant power.
Yeah.
I mean, it's not,
That's a good-
but I mean,
No, I started in
relative difference
'96.
to each other. That's a lot.
Yeah.
I
Turbine
started in
blades.
the '90s. Yeah. I started in '96 with the shaver heads within Philips. So I worked for Philips. Later on, they asked me to develop the process for turbine blades for the Joint Strike Fighter. So we went from the small shaver heads to the large turbine blades for the Aerofighter, the Joint Strike Fighter. And in 2003, I thought, okay, if we can do small and big, then there should be a lot of other opportunities. So that's where I started ECM Technologies roughly 20 years ago. And within ECM Technology, we did a lot of research, automotive, aerospace, medical industry. We worked for multinationals globally. And at the end, research is all fine. The reality is it takes twice the time and double the budget. So I think 3-4 years ago, we said, okay, where are we really making a difference? And that was in power sections, or actually back then in stators, or in the aerospace. And we said, okay, let's go full speed ahead in profiling. That's where we started company Easy Profile, and we grew into the metal to metal. So we also did some elastomer versions.
Wow.
Yeah.
I mean, it's just incredible to be able to, like, to go from that progression.
The step change. Yeah.
It was a big change within a company as well. Yeah. From research to high-tech production. Yeah.
So this is always interesting to me. How has your journey been in oil and gas so far? Because a lot of people that, you know, like myself and Aaron, this has been the majority of our careers.
Yeah, my entire career, except for
you know,
a heavy duty mechanic way back 10 lifetimes ago.
Yeah. I mean, I worked at UPS in college or whatever. So like, how has, you know, because obviously you had a career outside of this and then coming into oil and gas, how has that been for you?
I think the first step in was we worked for one of the majors. We built a dedicated process to profile status back in 2013-14. And that they said, hey guys, what you can do, nobody has presented that to us. So everybody was excited. So that was all good. And end of 14, they said, there's a good potential to do a few hundred up to maybe 1,000 stators. So we started excited January 2015, and not much later, I think mid-January, I got a phone call, got a production because the oil price dropped. So the first introduction into oil and gas was the waves in the market.
Good old oil and gas to let you down.
Yeah. Yeah. Hello and goodbye.
Yeah.
all at once.
Yeah.
Wow.
No, and that's something we built into our business model. So even those fluctuations, we know those will happen, but we build our business model around that to be able to be flexible as well in that regard.
So then Aaron, how did you get into the picture? Because obviously you weren't designing Norelco.
Right. No, I mean, I'm a directional driller by trade. So, I mean, I got my start with
Slide Monkey, as I prefer.
That's right, Slide Monkey. MWD, and worked into directional. I mean, over the years, torn up a lot of motors, right? And back in 2017, Hans and I had met through LinkedIn, through the power of LinkedIn. Met at OTC. I was still directional drilling, and what was it? COVID hit, and all of a sudden we started doing some communicating, and it was like, well, let's do this. I mean, in the heart of a downturn and COVID and everything else was going on, we identified some improvements and things we could do, and now we've got a very successful through tubing business. We're focused on growth into drilling motors. We're looking at pumps. We're looking at PCP downhole pumps, which is, I mean, call it a stator rotor. It's a power section or it's a pump, but either way you drive it. We're looking at all kinds of different things we can do with the technology now, and it's such a simple business. It's rotor and stators. We keep it as simple as we can. We just want to do power sections and pumps, and it's fun. It's taken something that's really dumb iron, and there's power section companies out there left, right, and center, massive facilities, and we're doing it with about 11 people, and it's fun.
So why the metal power sections? For Hans or
the Holy Grail.
Either one of you.
It's the Holy Grail. It's to remove one of the largest failure modes in downhole drilling motors. So removing the elastomer, you're not chunking.
I thought you were going to remove the MWD hand.
Right. Yeah. No, that's everyone else can do. Remove all the hands from location. We just want to provide power sections. And removing that failure mode keeps you on bottom drilling. Drilling plugs, whether it be cement, whether it be, obviously we want to transition into more on the drilling side. So, we're working on our high temperature capability is there already. We're tested to say 500 C. Thermal expansion between the two pieces is the same virtually. And so we're going to be very successful in the geothermal business is going to be the next big thing.
So Hans, maybe you can answer this. Why has nobody else done a metal to metal power section?
They've tried, yeah.
Or would have been, why wasn't that the first thing that the industry went for? And then, the other ones that have come before, like what is that big challenge there that's really presented? Because, obviously there's not, just like there's 50 MWD directional drilling companies, there's even more probably motor providers. Yeah. There's tons of drill bit companies, tons of rig operators, but there's few far between as far as metal to metal power sections. Why is that such a big challenge?
I think it's all driven by the technology that we have. Metal to metal has been a holy grail for 34 years, and several companies have tried it, and the majority has failed. And why would we succeed? And the reason for it is that we have the technology to make this stator within a hair thickness of accuracy from 1/11/16 up till future maybe 958, 11¾ machines are capable of handling those sizes, but being able to make this within a hair thickness of accuracy, so let's say in thou sizes 3 thou, that's where the difference comes from, and nobody has been able to realize that. And like I mentioned, shaver head technology, aerospace, all our background has always been around electrochemical machining. So it's not a mechanical machining process where we're removing the metal. It's all based on electrolysis. So I always call it a high-tech corrosion process, but we're able to do that so accurately that we have that tight fit between rotor and stator.
So all of this has been just made possible by y'all's IP on the machining side.
Yeah, correct.
Yep.
How long did that take to be able to develop?
Yeah, I once had the comparison between the shaver heads are made on micrometer level accuracy. So these are within 2 micrometer accuracy. And we always took that as a standard into the aerospace, and that always has been our learning school. Like I just mentioned, we have been working aerospace, automotive, has always been fun, and we learned really a lot about electrochemical machining. So I think collectively within a team, we might have between the 150 to 200 years experience on ECM, and that's I think the crucial part of making this feasible, and that's what we have integrated into this process. So we know there are a few other companies in the world using ECM to profile stators, but it's all for even wall, and they're far off in accuracy to be able to maintain that accuracy. If this is just a few thou too small, and this one is a few thou too thick, it doesn't fit. And if this is a few thou too big and this too small, you have too much leakage. So you need to have that consistency and performance for each power section. And that's, I think, the great thing we have is that rotor and stator, it's not the perfect, it's not directly a set. These are interchangeable because of the consistency of that process that we have here. These other machines are not available on the market. It's developed by the own team here, and we just bought all components from the market, all designed specifically for this process.
Wow.
Yeah, that's pretty cool.
So what is the big challenge with being able to get the adoption in the industry of people being able to use metal to metal power sections? Now, obviously, this is a operational, like operational risk component. So like if it fails, you got to trip out a hole. So it's not like, you know, a sensor that you could just put down there and see like, oh, let's see if it works while we're drilling. Right. So, I mean, there's that, but what are the other, you know, obstacles that you guys are facing to get adoption on these?
The big part of it is sort of educating people on it and really seeing is believing. I mean, you know, for a few years now, I've run around the country everywhere with a power section, a motor in the back of my truck, and dyno. Just being able to see that thing on the dyno and prove that we can make power, unbelievable amounts of power, right? I mean, that's the downhole drilling motors. I mean, that's what you want. You want torque. You want power. And we've been able to really show people. I mean, you see people's eyes light up when they see this thing on the dyno. It's really incredible technology. And then they put it down hole and they're able to drill multiple wells back to back, where you have a power section, drill a well, maybe you pump some acid, maybe you pump some nitrogen, that stator's throwaway. Can't be reused. And we've got people reusing these over and over in hundreds of hours. So now you've sort of made a cost benefit for the power section, and it makes sense. You're not you've eliminated a failure mode, and you're able to keep the same power section drilling over and over and over again.
So as far as power output, is this comparable to like a typical elastomer rotor stator configuration?
Definitely, yeah. We're equal or more so, and we have the ability to change whatever we want basically with it because of how we manufacture. So if you need a custom power section with, you know, I mean, obviously we try to keep things as short as possible, but we can tweak any component of that power section to meet whatever needs you have. We have people coming to us all the time, you know, if it's maybe a casing cutter, or they want a high speed or a low speed, or, you know, extended reach tools. The power sections can be used in short version for extended reach tools. We get all kinds of really off the ball, you know, we want something to go reverse, we want it to go spin the other way. We can do that, and it's all the same machine, whether it's, you know, the size of a pencil, whether it's, you know, 12-inch in diameter, whether it's 6 feet in length, whether it's 25 feet in length. We can do it all on the same machine, and it's so versatile.
That's a pretty important piece of machinery.
It's game changing. It's game changing. It's really cool. Yeah.
So what has been the, oh, go ahead, Hans. Sorry.
One thing to add is size and length, but it's also rotor and stator are both but done on the same
components.
We just have one type of production line and that multiple, but it's only one line that has the capability of doing everything. And even between power section, we can do the pumps as well. So one type of machine being able to do the whole gamma.
Yeah. Well, I feel like that's shrouded in secrecy. Like that's why it's probably, is it in the Netherlands?
Yeah.
Or
Yeah.
Oh yeah.
It's kind of, that's
nobody's going to just be peeking over the fence.
That's right. That's kind of like the black box around it is, you know, we're keeping it over there. People ask us all the time, are you going to bring operations to the US? Absolutely never. There's no case for it. I mean, we can ship product. It's all fairly small stuff, air freight. We can move it here in a week. You know, we could put product on the ground here if we need. You know, we're selling everything we get that comes in. You know, we're mill runs worth of material. We're now operating in the 2 years we've been doing this in like 23 different countries now. So it's grown. It's just perpetually getting better and better and more exciting. So we're all the time. We're just like, what's going to be the 24th country? You know, who's going to take it on next?
Who do you think is going to be the next country?
I don't know. We kind of talked about that. It's hard to say. I mean, we get such oddball stuff that just shows up all the time, and it's like, okay, well, it's going to Romania this week, or, you know, I mean, it could be anything. I don't know. Hans, do you make a guess what the next country would be?
Maybe Northern Africa or Kazakhstan.
Oh yeah.
Yeah.
Go to Kazakhstan, take some pictures.
Okay.
So, what has been like the initial feedback from clients that have run it?
I mean, most people are immediately just blown away. I mean, you got something that puts out so much horsepower, so much torque. From the through tubing side, these guys that are drilling plugs and all this kind of stuff, it's a little bit getting used to. It's kind of like, you know, when we first came out with even wall motors and how they react down hole. There's no forgiveness. So you've got metal to metal. All that power is there when the pressure is there, when that bit engages, the torque goes up, the pressure goes up. But it's allowing these things to go to work and putting them on bottom and put them on a plug, putting them on cement or whatever you're drilling, and let that pressure come up. Don't that knee-jerk reaction of pulling off bottom. Let it go to work. And that's the biggest thing, is just getting used to how they operate.
So are these lasting just as long?
Way longer. Yeah, we got people that say an operation, a couple operators, a bunch of operators now. Mexico blew up on us. They've been some of our best customers. They typically will run 3 runs in the hole. They'll do an operation where they pump acid. They'll go pump nitrogen, and they'll pump solvents like xylenes and stuff like that. So it's typically 3 runs in and out of the hole. This is all the completion side, right? It's been a big learning.
I've got no idea what's going on there at all.
3 runs in and out of the hole. These guys are now where you'd have 3 stators essentially thrown away because you've done acid, you've done nitrogen, and you've done some xylene. That elastomer just doesn't last. So now they've gone in the hole. They can do all 3 operations on one power section. So there's three stators you've saved. And they've done that over 10 times now. So that's 30 stators. And they're still going.
Wow.
So
what are the drawbacks though? Like this, like what's like, can we pump all the sand we want? Because I'm guessing that's probably not.
I mean, that's our Achilles heel right now is abrasives. That's why, you know, the through tubing side, coil tubing, you know, all that kind of they're really running on fresh water or I guess recirculated stuff from downhole. It's cleaner environment. Drilling side's a whole other ball of wax, and that's something we need to overcome, and we're working on that. That's the last piece of the puzzle. Is like longevity. We're there with through tubing. I mean, it works so well. The drilling side with just drilling fluids. We've had some amazing success with the rotary steerable in the Middle East. 180-hour run could easily go for another 180 hours. Another run, you know, what we thought was fairly similar mud conditions, not at all. You know, you're not getting longevity out of there. So we've got work to do. That's something, you know, we will always be constant improvement on. But right now, you know, we see a huge opportunity, and we're talking to a lot of people in the geothermal space. Again, these guys aren't taking the same fluids and the same mud from location to location to location, full of suds, you know, or sand and solids.
Yeah, just letting that mud tank just like fill up with West Texas sand blowing in the top of it, and then they all said, "Yeah, let's let that sand settle all to the bottom."
Why are my flow diverters washed out? Why are my MWD tools washed out?
There might be a cause.
There might be a cause, and we have to overcome that because that's not going to change. So we're working on a lot of, you know, treatment processes and things that we can do. We're working on that.
I mean, do you think the industry could change if we could show them like, hey, look, if you took an extra 5 minutes of having better mud practices,
right? Places like the Haynesville that is hot, right? And we're doing everything we can to overcome. We want MWD tools to be hot hole. That's going to open up, of course, more with geothermal. I mean, a lot of these service companies are always, I mean, no matter what, it's affecting, you know, the amount of MWD tools, like the amount of wash, the amount of components they're having to fix. And if we could just get the mud cleaned up, that's something the operators have to.
They have to be
realize.
The champion.
They have to do it.
Okay,
fix it. So we have some work to do there, but geothermal space. I mean,
tell me about
a lot of
geothermal
geothermal
stuff.
space. So geothermal, fresh water. I mean, we see a huge opportunity for that, and that's going to be the goal for the next upcoming years, to start doing some stuff like maybe a 9 5/8 motor. These guys want to drill 12 1/4 hole to 400 degrees C. You know, they want super critical. Now there's nothing that can touch that. So we can. So let's,
other than just straight pipe.
Yeah. No surveys, no nothing, but we can do it. So we're only one small component of that, but we're a big one.
So then tell me this, because obviously you guys have been, you know, Hans, I've seen your pictures of going to the PB&J thing or whatever that was, or P&J Live.
Yeah, the Aberdeen, yes, that was the Icota.
Icota. You guys did Adipec.
Yep.
You guys did SPATCE, OTC. You guys are hitting all the major events. Like, I mean, if anybody should be able to tell us what's really going on in the industry, it's you guys.
Yeah.
So obviously you guys started this with doing oil and gas applications. Since then to now, the level of interest in geothermal drilling, how much has that increased?
I would say a huge amount. I mean, it's gone from, say, like the pivot, what was it, 2019 when that all started. You know, just the realization of what geothermal is about and what the potential is, and the need for it. I mean, we need base load energy, and we're not getting that from wind, solar, everything else. I think the realization and now is really sort of lit the fire under everybody, and everyone's looking for hot hole answers to how we can get to supercritical. That's the answer, is supercritical. We need to be able to drill anywhere in the world down to a depth where things are so hot that energy is there, and lots of it. So we kind of fix kind of a small component of that as well. And it's just our place in the industry where we see it. There's companies out there like Quays and GA that they're doing some really cool stuff. I mean, millimeter wave. I mean, they're vaporizing rock and doing some really, really cool stuff. There's no doubt about it. But we're able to do a lot of that now. So we can make a hot, high temperature motor. And I think that's kind of our little space in it all.
When do you think that's going to start to happen, that people are going to start to pull the trigger? And
they are already. I mean, we see projects coming up. They're sort of in the planning stages right now, but I mean, they've selected wells. There's stuff going on from, say, Alaska on all through the U.S. There's, you know, looking at repurposing wells, which, I mean, what better thing to do with all our high temperature oil and gas, right? Repurpose all that stuff. So we see it all over the world. Great companies like Ever out there doing some cool stuff, and they're global now. There's a lot of really cool opportunity in geothermal. So,
Hans, what about you? What are you seeing from all the different events that you're attending?
I went to a few geothermal congresses, like in Iceland. That was last year, but we exhibited in Berlin last month, and I visited Turkey, Izmir. What you see there is indeed a lot of opportunity there. You see a lot of posts on LinkedIn as well going around geothermal. Geothermal is really picking up. Not by definition all is going up to beyond the current temperature limits for the elastomer motor. So not everything is going beyond the 170, 180 C. But definitely there is a large focus to get beyond that temperature. But here in the Netherlands as well, there's a lot of geothermal going on here as well. But it's just one up to 90, 100, 110 C. So there's no need for our motors. Of course, we would like to use them there, but there's no direct need. So the market is evolving in that direction. Like Aaron mentioned as well, the supercritical. That's where the full focus is, because you have 10 times more energy with supercritical than compared to 200C.
Well, I know we've got a whole bunch of questions here from the audience, but I want to ask you one more thing. What is the next evolution that you guys are seeing with your motor?
I think to move into more of the drilling stuff is the big next step change that we will make.
Yeah, I think just for now, we want to dominate the true tubing market. And from there, we will enter into the drilling sizes, and we will also enter into the pump sizes. So pump versions, artificial lift, PCP pumps. And I think that covers what we can do with this technology, with a stupid simple business model, only making rotor and stator with one single technology. Yeah. And I think the breakthrough at the end, one big issue always with metal to metal has been the sealing between the rotor and the stator. We still have a lot of stuff in our toolbox to make that gap even tighter. And then in theory, a power section doesn't have to be longer than 1.1 stage. While in the drilling sizes, you see everything going up to 10, 11, 12 stages. They become longer and longer. For us, they will become shorter and shorter. With the through tubing sizes, we started with, let's say, 5, 6 stages, roughly 7 feet in length. I think next year we will cut them all in half, and the sweet spot will be around 2.5, 3 stages. So you get nice short power sections. And that
From
will...
a well placement perspective, right? I mean, motors keep getting longer and longer and longer, and your directional drillers trying to project more and more. Your bit to sensor is getting longer and longer and longer.
Yeah,
we're going the other way. We're getting shorter. So wellbore placement is going to get better using that. There's a lot of opportunities still.
Yeah,
still.
That's the focus for next year.
All right. So let me see. I know that we've gotten some people that have said some comments. Baker Hughes made an all metal mud motor over 10 years ago for high temp geothermal apps for the Department of Energy's Geothermal Technologies Office. Patent ? So I guess those are patents?
No, that was, I think, indeed research on the Department of Energy. I think they spent something like 10 or 15 million to get that up and running. Like I mentioned, we have a gap between rotor and stator of roughly a hair thickness. I think they were roughly around 30, 40 tau. And so it worked, but like putting on a dyno, I think there was limited performance. So they never continued with it. And then a downturn came 2015, and they lost a lot of knowledge in that time. And yeah, it was unfortunate.
Yeah, like the technology has been, I mean, the idea and the technology has been around, but the ability to do so and to execute it has just not been there until now. So that's
so Hans is right. See, as always, Hans is right. Getting a tight seal is key.
Yeah, it's all about fit. I mean, that's what makes the power. So everyone asks, I mean, we always, they see high lobe configurations and they start talking about speed and all that. Well, we have the ability, we like lots of sealing lines because we're not dealing with hysteresis in elastomer power sections. We're not dealing with all those impacts, destroying the elastomer, causing it to break down. We like the sealing line. So we run with higher lobe configurations. Right now, a 910 really works well for us. We can speed it up and slow it down because we have full capability to change pitch. And we can tweak a lot of that kind of thing to change speeds and output. Maybe in the future we look at higher lobe configurations and get things even shorter. We do have a 7/8 configuration and a 2 1/8 that works very, very well. So we've got a lot of sort of things that we've been able to tweak and change in the design.
That's cool. All right, next question we've got. What is the mean time between failure for metal to metal motors for Permian horizontal wells? That's John, geosteering and geothermal.
Yeah, so we just don't have that kind of data as of yet. I mean, we've only had a few runs on the drilling side, and we're not there yet. We know that. We're always looking for certain opportunities we've got some 5-inch motors. We've got 2 different designs, 0.53 rev per gallon, which is ideal for rotary steerable applications. And then we've got like a 0.84 rev per gallon, which is very, very, we've got a 910 6.8. It's very basically performance wise, it's a 6.780. On the dyno, I mean, it is on par with a 6.780. It's really impressive. We need more runs. I mean, there's no doubt about it. And that's why we're focused on the through tubing stuff, because we are so successful.
We'd yell at Cade and see if he'll put it.
Sure. But again, we're really picky with it because we know where we're going to be successful and we know where we're not. You know? So I mean, places like the Haynesville, we're not going to be there yet. So we're not gonna mess with it right now. That's the future. I mean, that's where we want to be. That's where we have to be. You know. But we're solely focused on the through tubing. There's a lot of potential in geothermal because of fresh water, basically drilling with fresh
So
water.
I mean, even through tubing hot hole applications. As well.
Sure. I mean, hundreds of hours. So I mean, you know, between through tubing and Haynesville, that's fine. I mean, through tubing, we've got probably 4 or 5 companies, 6 companies here in the U.S. now that are running metal or full metal power on their through tubing stuff. So, and it's becoming, and they're reordering and more and more and more. So it's cool. Yeah.
Excellent.
Yeah.
All right. Next question. What is the tolerance for LCM? Are the tolerance so tight that conventional materials like nut plug would be pulverized before getting through the tool?
Yeah. So some interesting stuff that kind of came about on you know, a rotary steel will run was basically typical operation. Previous operation was cementing, right? Previous operation, they skid over, pick up drill pipe again, pick up BHA, start running in the hole. All of a sudden, start bending pipe through the curve. And what happens is all that scale that they failed to clean out of their pipe ends up going through the motor and ends up in a pipe screen or somewhere else. And we had an impressive amount of nasty looking gravel and cement and all kinds of stuff that went through that motor. So that really gave us a lot of hope when it comes to what LCM is going to do. I would say anything fibrous, you're going to have problems more in your flow diverters and places like that where it's going to plug. Yeah, absolutely, they're going to plug off, but I don't think there'd be any difference between an elastomer plugging off and metal to metal.
You of course
have nut plugs, all that kind of stuff, no problem.
You have the cavity between the rotor and stator, which circulates all down through the motor. And that goes roughly 95% goes through that cavity and is just transported from top to bottom. And just a small amount is squeezed to as leak path. And so having that crunched or pulverized, like asked here, is just a very small fraction. The majority goes with the bulk.
Yeah.
Okay. All right. Next one. How does the horsepower compare metal to metal versus pre-contoured versus normal rubber power drop motors?
So, I mean, comparing
or positive displacement motors.
PDM. So when you compare just an elastomer power section, you really need to be able to compare apples to apples. So you're looking, when we design a power section, we look at what we want to put output. So it's usually on par. We don't need to make anything that's more powerful than anything else out there. We need something that's going to be application, you know, a benefit to the application. We don't need to twist off pipe. We don't need to make anything so ridiculously powerful that we're just going to end up breaking stuff. We don't want to cause problems. We just want to be able to stay in the ground, complete these jobs, and repeatability. We want you to take that same power section, go to the next job, and do it all over again.
Just rack it back.
I mean,
well, I guess they're not
flush it
racking
out.
back.
You know,
I don't know if they're racking them back.
Take care of your stuff, no matter what. I mean,
yeah.
You know, put some oil in that thing. But when it comes to like the drilling motor, we were tasked to make, and you know, comparable to a 6780, we are on par. Torque, RPM, and more so because it reacts like an even wall, right? But without any rubber. Everything's very linear, so we maintain RPM, we maintain torque, very nice. Where the elastomer starts to under load, starts to distort, and your curves start to drop off. Ours remain very flat and just keep going. So they react more like an even wall motor in that regard.
No, and even no derating needed, huh?
Right, and that's the other thing. In high temperatures, you know, you're derating these motors. You're not able to run on them, you know, as hard, 100% of book value, you know, that you normally would. You're running at 60%. There's no need for that. You push on it just as hard as you would from heel to toe, whether it's 150 degrees or, you know, 280 degrees. So there's a big benefit to that.
And one thing maybe to add is, as the power is there, and we have some clients, they say these are too powerful, they cut off a few feet. That gives us also the opportunity to shorten them next year, because they have the power that what is needed, and they shouldn't be too powerful, like Aaron just mentioned.
Yeah. There's a lot of people that just sort of fine tune for their operation. They know they can cut. You don't
need a supercharger in a minivan.
No, you really don't.
Not to say
you want to.
I mean, not to say it's a minivan, but I'm just saying,
right.
We
sell it supercharged, but you might need to down tune it a little bit. But yeah,
you don't want to be giving some of those DDs that much power.
I know, this is the thing, because we're going to use it. We're going to mash on it.
Yeah, we're going to destroy some stuff. All right. LinkedIn user says, do you see any corrosion issues with high percentage, NACL or KCL?
Right. So high chlorides. Chlorides, chemicals is not really an issue for us. I mean, most of everything we do is all nitrided. It's a very hard surface. It works very well for us. Of course, we got a lot of people pumping acids and stuff like that. The acids attack carbon. They're still able to run these things, at standard acid concentrations, which is usually between, say, 7 and 15%. There's other people out there that have tried 31%. It's all how you treat it. I mean, you're going to be able to stay in the ground. You're going to be able to do these jobs over and over again. We've seen these things come out covered in this black, horrible scale, and they just keep going and they keep running. I mean, it looks nasty. Sure, there's some pitting that happens with acids and stuff like that, but the sealing lines are still intact and they're still running, and it's incredible to see. So that's a huge game changer. I mean, nitrogen, that's another big one. Chlorides, not an issue.
Well, there you go. All right, next question. Hi from Oman. Okay, thank you guys for being here. With the torque production of the tool, have operators had to change the bit styles and drill string connections in the BHA that they use?
That's a good question. I mean, we haven't got enough runs on, say, the drilling side yet. I mean, again, these are high torque motors. I mean, they're designed to keep up with anything on the market that's putting out. So from my perspective, I would always say, look at high torque connections. We don't do anything to do with bearing packs. We only manufacture power sections. So that's up to X company that's purchasing these to really, we provide drawings, everything to do with it. Look at your connections. If you want to run FEAs, you need to do your homework and do what's best for your fleet. Yes, I would always recommend high torque connections.
Probably a good general practice there.
That's the way the whole industry is going.
All right, Darius, there are multiple uses of geothermal, from district heat loops to heat pumps and base load power. Look at Clark Lake for reuse and Dutch Harbor for base load for district heat.
Agreed.
Excellent.
Agreed.
Okay.
Yep.
All right.
It's cool to see all these geothermal projects that are.
Unfortunately, we'll have to watch it over. One question though, with referencing to thermal expansion of the rotor and stator, expansion will occur equally in each direction, leading to a narrower flow path and thus increased pressure and temperatures. Can you give a figure in terms of the degree of influence this has?
Less than 1%.
Going
asking the tough questions.
Thanks, Boone. No, what we have done, we heated this up in an oven up to 450 or 500 C, and it was phenomenal how consistent it is. So that change is or the difference. The change is there, but difference in performance, like Aaron mentioned, this is less than 1%.
Yeah. All right. And Darren says, should downhole screen be used with this power section?
I mean, it just depends on your fluids. I mean, it's something I would recommend running a screen. Try and keep your fluids as clean as possible, just like anything, right? Again, abrasives are hard to filter out. So if you're in high abrasive formations or environments, then you want to try and take care of those abrasives. But aside, I mean, on the completion world, yeah, there's high abrasive areas, but I mean, these things are still outlasting. I mean, that's the thing, is you're no matter what, the thing's still going to spin. So there's a lot of you're going to come out of the ground. It's still you're not going to be stuck in the hole. You're still going to be able to circulate, even if that thing's worn completely.
You're not going to be plugging up jets,
right?
If you do, then something else has gone drastically.
Yes, you got swab cups in the hole.
All right, Darren asks, what's the maximum cutback on the power sections if the connections were damaged?
I mean, that's kind of the nice thing. Again, we provide a power section that's plenty long, so it puts out a lot of power. You can continue to cut these things down. It's really at your own discretion at what point you say that power section is retired. But at the same time, again, on the completion world, especially if you're just doing cleanouts and stuff, you've got an old power section out back that's been running acid jobs and run all over the planet, and it's pretty tired, but it still spins. You can go in spot acid. You can go in and do a quick clean out with it. You don't need a whole bunch of torque to do a job like that. So they're really versatile. It's up to yourself when, how much you cut it back, how much your NDT inspection, everything looks like. You can still run them. I mean, there's still really usable applications for them, even after, usable life, call it.
Wow. So do most clients, are you guys like renting, leasing, or just like straight selling?
We just sell power sections.
Okay. Yeah. So you guys don't, so once you say goodbye to them, y'all don't see them again?
No. I mean, I go visit customers.
Well,
we get the feedback, right?
Yeah. But they don't come back to the shop afterwards or anything like that.
No, they're a fire and forget. But I mean, the life on them is so much greater than we could have even expected in a lot of situations.
So on a normal through tubing motor, what would the normal life on that be?
I mean, we're trying to,
like if without
we've
like
got
some kind of chemical
from
exposure.
500 hours to 1,000 hours. So I mean, that's a grotesque amount of hours for a power section of any variety. But yeah, so I mean, again,
you could sell a lot more if you didn't achieve those numbers.
Yeah. We need to fix that in some situations. But no, I mean, that's what makes it so cost effective. It's not about capex. It's your opex, and you've got something that's just going to run and run and run. From the operator's perspective, I mean, you're saving trips in and out of the hole. It's a really cool addition to your fleet to be able to say that. And we've got operators now that are requesting, and that's where we get a lot of like, hey, we need these power sections in here. The operators are requesting this stuff now, which is really cool.
Yeah. Right. And based on this, like I mentioned, at least 1.1 stage, but Robert, you can really cut back a lot before it's not functioning anymore. But also I think the ESG side is phenomenal with this power section. So no landfill with all the rubber. Our side product is from the process is hydrogen gas. So it's cradle to grave. It's literally metal to metal. It comes from a mill, ends up in the mill, and no waste beside it.
Yeah, fully recyclable. I mean, we have iron oxide as a byproduct, which is used in dyes and stuff like that. We've got hydrogen, and we've got salt water, which is scrubbed and filtered and reused as our electrolyte. So, I mean, again, the same machine does both components, stator and rotor, from small to big, rotor, stator. It's all the same machine. It's the same process. It's such a lean design. It's such a lean facility. It's incredible compared to what you'd see in a reline facility.
I want to go see the facility.
Yeah. Come on, you're welcome.
All right.
We invite anybody. Come.
Got myself invited. There we go.
Come have a look.
Come on King's Day. Everybody's dressed up in orange.
All right, there we go. Perfect time not to stand out. What have you found is the longest safe power section to avoid jamming in dog legs and borehole curves?
So again, we don't have enough data on that. We've got rotary steerable runs. I've seen dog legs of 6 and 7 degrees, pretty typical. We haven't drilled any curves yet, but again, the power sections are so much shorter than a typical rubber elastomer power section that I think it's not going to be an issue. Dog legs, we haven't done any real big testing where we put a lot of side load, like on a dyno or something like that. The initial designs,
Let's break it,
right? It's always let's break it. The initial designs when rotors were manufactured through another process, on a Weingarten or whatever, and the consistency wasn't there yet, and the rotors were banana shaped and the stators were banana shaped, and you put those two bananas together and they still spin. So that's sort of telling you, how much that can be bent and still function. So there's still a lot of unknowns with it, but through tubing, again, it's just we haven't seen any issues with it yet. They become shorter, and that becomes easier.
All right. Kazim says, "What is the metal-to-metal power section respond to motor stallings, as they would not deform by pressure?" Yes. What do you do? So that's what you were saying earlier. Is as the pressure comes up, don't.
So let it work, let it do its thing, but also be very aware that if that thing's gonna stall, chances are your rig is gonna become limited first. So your pumps and your pop-offs you're gonna blow a pop-off or something like that.
So you're gonna blow a pop-off before you stall this.
Yeah. So know your hoisting off bottom procedures. Let it relax, let it do its thing before you yard it off bottom.
Wow.
That's gonna be a lot of trap torque downhole.
Just imagine.
But I mean, elastomer motors nowadays, I mean, they're monsters. It's the same thing. Don't yard it off bottom. Any company out there, directional company, all the drilling companies should know. You're always trying to slap that driller's hand away before he sucks it off bottom. These things have a lot of torque to them, and there's not a lot of place for that torque to go except for in the string. So,
all right. So I think we got through all of the audience questions there. We didn't skip any. All right. Wow. Anything else you guys want to talk about? I mean, I think we've gone through a lot.
We've covered a lot of stuff. Yeah. I mean, we welcome calls, questions. I mean, hit us with the hard questions. I mean, it's exciting to get people sort of educated on this, the capability of the technology. We've got more customers posting stuff on LinkedIn. Latin America has been huge for us this last few months, and things are blowing up down there. We're seeing activity levels all over pick up. Of course, here in the U.S. is getting busier, so people are getting excited about it. The word's starting to travel, and this is where it kind of gets exciting for a small company like us. Like we're kind of in that growth mode right now, and we're really focused. We don't have big fancy websites, and that stuff's coming, but we've put everything back into the technology itself. We want a product, and that's what at the end of the day, the product speaks for itself. So it sells itself. Once people get a hold of this stuff, it's all about the product. I mean, it's really cool to see. It's different than anything I've ever been a part of before, especially in the drilling industry and
the stuff that we've been through. Yeah,
I mean, it's cool. There's cool stuff going on out there, and there's some great directional companies and great MWD tools, and it's interesting to see. But this is like unlike anything else out there.
What's the biggest power section y'all built so far?
5-inch. Just a 5-inch. Yeah.
So what's the biggest request that you guys have had?
11 and 3/4. It's gonna be a monster. Yeah, wow. It's gonna be big and heavy. We're not there yet. Probably the 9 and 5/8 will probably be a popular one. I especially think with geothermal, right? Because those guys want to take those 12 1/4 holes deep and hot. And it's hard rock. You're drilling granite, you're drilling some real hard stuff. And I think that's going to be an exciting one to do, the 9 and 5/8.
All right. Yeah. Hans, anything from you, sir?
The only thing I can say, I really enjoyed the last couple of years working on this project and this technology and getting this to the market and see how excited everybody is about it. So no, we'll keep on going.
All right, my last question for you guys. Did y'all get the idea for the bright colors? Was that because y'all saw me do my bright?
Because of you? I don't know. It started.
I know we did it about. I mean,
It
I
was
thought
at
it
the
was like
ICOTA,
from,
the ICOTA show last year, right?
March.
So y'all did it before me then.
Oh, see, we were first.
I didn't want to reply on your message back then.
Steal your thing. We were talking about it, David and I, before the show and stuff today, and it's just branding is everything. I mean, it's such a horrible color, but people recognize us from a mile away. At the Adipec show, even the guy at the door tags was like, "Hey, I saw you yesterday." You're like, "Yep." And people
That's
ask,
right, you did.
Yeah, you have a booth here? Like, no, we don't have a booth here. This is the walking booth. I mean, people recognize it. It's they see the brand and they see the logo and they ask questions, even if they're not even in our space at all. They'll ask, "What do you guys do?" And it sort of just drums up conversation and
then that gets you introduced. I mean, that is such an important thing.
It's all about introductions and
That
hey,
gets
you need
somebody-
to talk to this guy.
Yeah, hey,
and,
let me walk you over here real quick and
Yeah.
introduce you to somebody.
And LinkedIn has been, a horsepower of everything we do. I mean, it's all been LinkedIn. It's our relationships on LinkedIn and connections on LinkedIn, and people reach out through LinkedIn. All that stuff a website doesn't do. I mean, there's no social aspect of it. People just randomly ask questions about it. On the road, we're talking to people. This year's been big. We're kind of identifying what shows we want to either exhibit at, but at the same time, like not exhibiting at these shows gives us the ability to talk to more people. We're on the floor. People are dragging us over. We usually have power sections that people can put their hands on and look at it, and that's what gets people excited. It's that interaction, and it's really cool.
I had the same thing yesterday when I was at the ICOTA show in Aberdeen. It was a small sized show. I think 300, 400 people were there, but I had 8 coming to me. I saw you walking on Adipec. So the green shirts are so successful and so different than all the gray, blue, and black suits.
And the matching shoes.
It started as kind of joke, but yeah, we're just using it now as a branding. It's fun.
Yeah.
All right, Hans, I got to ask you. I want to be able to get an STL file to be able to print out one of y'all's power sections to mate it up with one of these Gibson Reports drill bits.
You'll get one. And otherwise,
All
I'll
right.
send you a 3D printed. We have a printer here as well.
Well, I want to be able to print out some of my own.
He's got his own printer here.
I got my own printer here. I got a big
I'll
one.
send you the STL. No worries. It's good.
There we go. There we go. And then the goal is we're gonna take that and we'll put on the end of your power section, put some threads on there so that I can make hook it up to a water hose. And then we're gonna just take it around out back and just start drilling holes
in the garden.
Drilling holes in the ground with plastic to plastic.
There you go.
Full plastic power section. So, all right, Hans, thank you so much for joining us, sir. I know it's a little bit later. Where are you still in Scotland, Aberdeen? Where you at?
No, I flew back this morning.
Oh,
so
you flew back.
I'm back in the Netherlands. Yeah.
It's obviously it's probably beer 30 where you are, sir. So thank you so much for joining us. We really do appreciate it. And thank you so much for being here. Hans, I would shake your hand, but you are a little bit far away. So
thanks for having us over.
It's awesome to be able to hear about it. I know I've heard a lot of it from you, but I think it's a great thing for the industry to be able to hear that, like, the crossover of technology to go from, razor blades to this, and neither one of you obviously shave like that, so that adds even more to it. So Hans, thanks for being here, everybody. Thanks you guys so much for watching. Next week I'm gonna be taking the week off. It's Thanksgiving. So it's time to be able to eat turkey, spend time with your family. So we won't be doing a show week after that. I've got to get somebody lined up. And then after that week, we've got Aaron Eddy, and then I got to get another show lined up. So if you know somebody or if you yourself want to be on the show, just give me a shout, or Tracy. Or we've also got a new team member here. Will Daughter is our videographer. So he's the one setting everything up this week, and as well as doing a whole bunch of really cool video content. So We're really, really happy to be able to have Will on the team, and thank you so much for being here, sir, and all of his hard work. I don't know. I think that's about it for this week. Yeah, I think that's it. All right. Thank you guys all so much for watching. Follow us on LinkedIn. Like, share, subscribe, do all the social media things. And as always, know your industry.